All right, you guys, so for this video, there's a worksheet online that goes with it. If you have a printer, you can just print it out. Otherwise, you can just write the problems down on a separate piece of paper, okay? All right, so the first problem, make sure you see that there's two vectors that are given. We're going to use that for problems 1 and 2. It says find the magnitude of 2w minus v. So when you do a problem like this, you do have to find the inside first. So just kind of ignore the magnitude for a second. And you're going to do twice w, okay, minus v. Make sure you put parentheses around that, okay. So 2w minus v equals negative 4i plus 2j plus 3i plus 7j, okay. And then, of course, you're just going to add like terms. You're going to get negative I plus 9j. Okay, and then when you find the magnitude of that, okay, you can draw it out if it helps you, okay. A little picture would look like this, where this is -1 and this is 9. Basically, when you find magnitude, you're just finding the hypotenuse right there of a right triangle. When you find the hypotenuse, you just do -1 squared plus 9 squared, and then, of course, you would square root that. So if you're ready for it, a little shortcut would be -1 squared plus 9 squared, square root that, okay? Just be careful here. Obviously, you can leave the negative off because 1 squared and -1 squared are the same. But if you do put the negative in, you do have to put parentheses around it. Otherwise, your calculator will give you the wrong answer. So just be careful, okay? So this is 2w minus v, okay? This is the square root of 1 plus 81, okay? And then the square root of 82 does not reduce, but if it did, you would reduce that, okay? All right, so the next problem says draw v plus w. So remember, when you draw, you always want to start at the origin, and then v is -3, and then 1, 2, 3, 4, 5, 6, 7. Okay, so that's a picture of v. And then when you do w, when you add vectors, you have to add it to the tip right here. So you're going to do -2 plus 1 like that. Okay. And then don't forget that you do have to draw the result, okay? So I'm going to draw the result in a different color. Okay, the result is that I started from here and I ended here. And you do have to put an arrow on that, okay? So if you wanted to label it, this would be V, this would be W, and this would be V plus W, okay? All right, so here's the trick on this. It says find the direction of v plus w. Direction, remember, is starting at the positive x-axis, going all the way around to here. Okay, so we know the direction is bigger than 180, okay, and less than 270. Okay, but you can't just find this, right? It has to be part of a triangle. So this is going to be the key to a lot of the problems going forward. You have to make the result vector the hypotenuse of a right triangle. So what I'm going to do is I'm going to go over, and I'm going to go down, and then I'm going to use that green triangle to find this angle right here. If I know that angle, then of course I can just add it to 180 and get my direction. Okay, so again, the key to the problem is to make the result vector the hypotenuse of a right triangle. Okay, all right, when you set this up, you'd say the tangent of theta equals, and then you have to count. This is 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5, 6, which you also could have gotten just by adding these together, of course. Okay, so the tangent is -6 over -5. Okay, do tan inverse of that, okay, in your calculator, and your calculator will give you 50.194, okay? That's just this angle, okay? So then, of course, since you're going here all the way around plus that, so this one right here is 50.194, then you have to add 180 to that to get the true direction. So the direction is 230.194 degrees. Okay, the key to this problem, the thing that most people mess up on, is just that they have a direction that doesn't match their picture. So just make sure that, you know, your answer makes sense, so you don't accidentally give me 50 instead. Okay. All right, number 3 is not related to the vectors given in the original problem. It's completely different. So this one says there's a vector u. It has a magnitude of 56. Okay, and has a bearing of south 12 west. So let me just draw that out for you. South 12 west would be like here-ish. Okay, All right, so the trick, hopefully you guys remember this formula we learned last time. This is how you write a vector if you're given the magnitude and the direction. Okay, so we have the magnitude that was given us 56. We do need to find theta, which is not 12, right? So theta is the direction, which is all the way around to here. So it's 180 to here. And if that is 12, okay, then it's going to be 90 minus 12, okay, which is another 78 degrees, okay? Or, of course, you could do 270 minus 12 to get that, okay? In any case, it's 258 would be the direction. So in this problem, theta is 258 degrees. So the most important thing, just be really careful, make sure you always use direction as your theta, okay? So then the rest is pretty straightforward. You do 56 cosine 258i plus 56 sine 258j, okay? Because 258 is not one of the unit circle angles, you type this into your calculator, you get negative 11.643i plus, oh, sorry, that's a minus. Let me get my correction tape. Okay. So I know it's a minus because I can see in the picture that the sign is negative, okay? All right, and then it's minus 54.337J. Okay, and then again, I urge you to look at your picture. Does it make sense that this could go over negative 11 and down negative 54? And, you know, it's not a guarantee you got it right, but at least, you know, it makes sense. Okay. All right, so the next problem we're going to do is kind of starting a new little type of problem that we're going to spend a couple days on, okay? This is like where you have, it's kind of like an application problem where you have two forces competing against each other. So I don't know if you guys, you know, fly much, but I always fly to New York about once a year. And the way there takes like an hour longer than the way back. And the reason is because the wind is going toward New York and so helps the plane. And then or opposite, on the way there, I think it slows the plane down. The winds are going against the plane. And then on the way home, the wind is going toward the plane, so it makes it go faster. And I could be screwing those two directions up. All I know is that one way takes about 6 hours and the other takes about 5 hours because of the winds preventing the plane from moving or helping the plane, okay? So they're called headwinds and tailwinds, right? In this class, we're not going to do direct headwinds and tailwinds because those are kind of easy. If you have a plane going directly north and there's a wind going directly north, well, then the vector would just be like this, and that you just add them together, okay? If you had a plane going directly north and a plane going directly south, then the vector would just be shorter. It would make it go slower. Okay, what we're going to do is we're going to do vectors that are at angles, okay? So on this one, we're going to have a boat, and then we're going to have a current, and the current is going to affect the direction of the boat, okay? All right, so we're starting off with kind of a nice one because I have the boat going just north. Tomorrow, or the next video, we'll have the vectors, both vectors going kind of in weird directions, okay? All right, so I want you guys just to start out. Just put like a dot down here. It goes north, so let's start down here a little bit. It says the rowboat is traveling due north, so just go straight up, due north. Okay, at 7 miles per hour. Now, what we always do is we just let the number of hours equal 1. Okay, because we want to know how long this is. So after 1 hour, if you're going 7 miles per hour, you've traveled 7 miles. Okay, of course, you can let the hours be 2 and say that that's 14, but it just complicates the problem unnecessarily. So we're just going to have it be 1 hour, which makes it go 7 miles, okay? So that's what the boat's doing. So we're going to call this vector B for boat. Okay, but however, there's a current that has, and this is without current, just like if the boat was in completely still water. Then there's a current and it has a rate of 3 miles an hour at north 40 west. Okay, what we're going to do is we're going to add the current to the boat to see what the result would be. And this is the tricky part. You have to add it to the tip, okay? So you're going to take the tip of the boat and you're going to add the current, which is north 40 west, like here. Okay, draw that one shorter because this one's only 3 miles in an hour, okay? This angle right here is 40 degrees, okay? All right, the result would be that the boat started here and ended up here. So if the person driving the boat, or rowing the boat, I guess, doesn't adjust, okay, then the boat will end up more to the west than it intended. But if you look at this green vector, it's longer than 7, so the current's actually going to help the boat go faster, which is kind of cool. Okay, so our job, we're going to call this C, is to find the boat plus the current. Okay, all right, so that you just start out by doing each vector separately. Okay, so the boat has a magnitude, so we're going to use this formula, remember. This formula you'll use all the time, okay? And because you're at home, you don't even really have to memorize this. You can just have it written down somewhere, okay? All right, so the boat has a vector of 7. And if you look straight up, would be 90 degrees. Okay, so we can do this one in our head. 7 cosine 90. Cosine of 90 is 0, so this means there's 0 in the I direction. Sine of 90 is 1, so there's 7 in the j direction, which you could have gotten, obviously, without using the 90 degrees. I just wanted to show you the format. So this makes sense because it goes 0 in the I direction, 7 in the j direction. Okay, so that's our boat. Now you have to do a separate one for the current. So the current is 3 miles an hour. Okay, but be careful right here, okay? So when you do the, trying to find a different color. Okay, when you do the boat, you can't use 40 because the direction is from here all the way to here. Okay, you always have to reference it from the positive x-axis. So that is the angle that we're going to use for the boat. So if you start here, you go 90 plus another 40. So the boat is going at 130 degrees. Okay, and obviously it makes sense that you wouldn't use 40 because 40 is in quadrant 1 and this vector is not going, quadrant 1 only goes northeast and this is not going northeast, okay? All right, so unlike on the boat, the 130 is not on the unit circle, so you do have to use a calculator for this. So you just type in 3 cosine 130 into your calculator and you get negative 1.928i. Oops, that's an I, okay? Which means that this boat right here goes over about a little bit less than 2, and it goes up 2.298. Okay. All right. So that's the boat. That's the current. Just do those separately. Okay. But what we really want is we want the boat plus the current. Okay. All you have to do is add like terms. So take the i's and add it to the I. Since one of them is 0, that's not hard. Negative 1.928j. Oh, I keep doing that. That's an I. I don't know why I'm doing that. Hold on. Okay. Hold on. Might as well make it perfect. Come on, tape. Oh, this tape does not like me today. Okay. And then here we add the j's. So we add 7 to 2.298 and you get 9.298. Okay. All right. So this vector right here, the one I'm boxing, represents this green line. Okay. All right. So this part's really important. Okay. We're going to try to find the magnitude of this. Okay, and then this is what we have to do. It's really similar to problem number 2. Okay, we have the vector we want. You have to make that the hypotenuse of a right triangle like this. Okay, so we're going to use that green triangle. This tells us the component. So this says that we go over negative 1.928 and up 9.298. Okay. So now that we know the 2 legs of the triangle, we can easily find the length of it by using Pythagorean theorem. So square root, again, if you want to use that negative, make sure you put in parentheses. Okay, plus 9.298 squared. Okay, so just type that into your calculator. You should get something bigger than 7, obviously. Okay. In fact, you should get something bigger than that. And so if you don't, it just means you typed the negative in wrong, okay? So you get 9.496 miles per hour, okay? Make sure your magnitude's always longer than both sides, okay? All right, so now my boat, so this is the speed, okay? If it asks for speed, that's what it's talking about. So now the boat, with the help of the current, is going 9.496 miles per hour, which is over 2 miles an hour faster, about 2.5 miles an hour faster than it would be going on its own. So the current's helping this boat go fast, which is kind of nice. Okay, to find the direction, okay, in the picture, the direction measured from the positive x-axis is how big is this? Okay, that's the direction. Okay, I'll call that theta. Okay, but of course we can't find that one because it's not in a triangle. The only thing we're going to be able to find is this theta right here. I probably should have called that something different. I'll call this direction. Okay, so to find theta, we're going to use tangent. So the tangent of our angle equals 9.298 over negative 1.928. Okay, just do tan inverse in your calculator. And the calculator gives you negative 78.285. Okay, but of course you can't trust your calculator. There's two ways to think about this. Because negative 7, you know, if you were to draw this out, negative 78 would be here, which obviously that's not where our vector is. Our vector is here. Okay, so there's two ways to think of this. You can say, oh, I know that if I just add 180, I'll get the right answer because it's just directly across the circle. Or you can think of this as the positive, so 78.285, and then you can do 180 minus that because you know that this, whatever that is, this is the supplement of that. Okay, it's however you want to think about it. So just add 180 to that is how I usually do it. And then so you get the direction. Hold on, let me make sure I'm still in. Yeah, direction is 101.715. Okay, so I want you guys to try this problem in your homework. These, you know, these have a lot of steps, so they are kind of hard. Make sure you use vectors. And then the next video, we're going to do a couple more of these for practice. Okay? All right, guys. Bye.